All right, we're back. Awesome. I'm having a few minor technical hiccups here again, uh, but it's all good. I think we're gonna figure it out here. So thanks for tuning in again. Michael Walter here, live from my basement, building things on AWS with Go and serverless and all that good stuff. Uh, yeah, I have even less notes and preparation from last week this time. So it's sure to be an interesting hour and a half because we're just going to basically try and make some stuff work. We're going to pick up where we left off last week. We're going to refactor our project a bit, refactor the code, do some more testing, and kind of get it to, in a little bit better shape than it was last week. That's the plan anyway. So we'll see how it goes. Um, but yeah, let's hold on one second. Let's get into here. Um, yep, there's my screen. That's not what I want to show. Let me just change my share here so it's a little bit more clear. Um, yeah, all right. So let's start taking a look at what we did last time and kind of do like a quick recap. So if you've been following along, if you've joined the last couple weeks, you'll know that we're building a project that basically generates poems using generative AI, using Amazon Bedrock, and it generates those poems inspired by artwork that we're pulling from the Cleveland Museum of Art's open access API. So let's jump over here to take a look. So this is the Cleveland Museum of Art collection. They have over 60,000 different artworks in their collection. So it's a really awesome collection of stuff to look at. And they have an open access API. So you can um, use the API to fetch information about any one of these artworks. And so what we're doing is we're taking um, the document that's returned from that API for any particular artwork, and we're kind of pumping that into uh, Amazon Bedrock using Claude Instant and asking it to use that document to inspire writing a short poem for us. So we got pretty far last couple weeks. We built most of what you see on screen here right now. So we have an API gateway in the front. We haven't done this CloudFront bit yet, but we'll get back to that eventually. And so a user can request a poem or a particular artwork rather, and then the API gateway will invoke a Lambda function, which is written in Go. And the Lambda function will fetch that artwork from the Cleveland Museum of Art's open API. It will feed that into Anthropic Claude Instant and get back a poem. But last week we introduced this idea of a database as kind of a cache. So rather than requesting those every single time, which can get kind of expensive and is a little bit slow in terms of performance, what we're going to do is we're going to save those to DynamoDB as they're generated so that the next requester, if they request the same artwork, they'll get the poem straight away. So last week we put all the code in place to do that. There was a couple little hiccups there that we're going to fix today. And yeah, and then I tried to run it locally and I was having some trouble, but when we finished the call, I deployed it all to AWS and I tried it out up there, and lo and behold, it worked just fine. So now we have the ability to put in an artwork ID, and if it's got the artwork in the database, it will just spit it right back out. So you can see it pretty quick. You couldn't even really see that one. Um, let's do one that's actually in the database, just as an example. So we go over to DynamoDB and we look at our table. We can see, just a second, let's make this a little bit bigger. We can see we've already got 4 artworks in here with poems already generated. So let's grab this one, 137125. And so if we go back to here, 137125, it immediately responds with the poem. So it's super quick. And so that's the whole idea. So what it did there, rather than fetching the artwork, generating the poem, and returning it to us, it circumvented that by looking in the database first. So it looked up that ID in the database, and since it found it, it was able to just return the poem straight away. And so that's the whole idea. If there is a poem existing in the database already, we just return it. If not, we generate one. So we can try one if you want to see. Let's try this one here. I had a couple copied and pasted from before. So if I put this ID, so this ID is not in the database yet. So 385929. So you'll see it's going to take several seconds, maybe 10 seconds. We'll see. So it's generating that poem. It's calling the Cleveland Museum of Art API, and then it's generating a poem with Claude Instant. And if all goes according to plan, it should show us the poem here. So here it is. So that's a new one. And so now, if we go into DynamoDB and we run our query again, now we have that new poem right here, right? So since it wasn't there in our diagram, so since the poem wasn't already in DynamoDB, it did this whole flow. It generated the poem, and then before spitting it back out to API Gateway, it saved it in the database, so that the next time we run the same one, it's pretty much instantaneous, just a couple of seconds, not even, to fetch the poem. So that's cool. It works, but there's a bunch of issues I kind of found in the code base last time after we closed the call last time, so that I thought it'd be fun to try to fix this time as kind of an exercise. So we're going to spend a bit of the time today just sort of refactoring things, dealing with errors a little bit better, and talking through some of the things you might want to think about if you're building an architecture like this. All right, so let me switch over to code editor mode. Hold 1 second. Here it is. Here's my code editor. So we're back in VS Code. One thing, just before I get started, so one thing we haven't really talked about yet is Git or GitHub. Yeah, it's definitely something that's kind of always there in terms of, we're always committing our code to Git. It's our source code repository. So I haven't, up until now, I haven't really mentioned Git. I was trying to sort of avoid thinking about it, but I feel like we're getting to a place where our code is changing enough where we want to start to keep a revision history. So I initialized this as a repository now. It's not on GitHub yet or anything, but it will be soon. So you'll be able to take a look at the code up there. But for now, I just wanted to point out that VS Code, you can deal with Git very easily. So you can see any changes you've made. You can publish your commits up to GitHub. But also when we open our terminal, let's clear this up. You'll see that we're on the main branch. So now that this is a GitHub repository, it's a little bit more aware of that. So that's kind of nice. I just wanted to kind of mention that. And one other thing to mention is that I added a git ignore file. And a git ignore file basically just tells Git not to commit certain folders or certain files in your directory. So we're going to ignore this SAM, AWS SAM directory. That's where all the SAM artifacts get built as you build stuff with AWS SAM. And I'm also not going to commit this SAM config file just because we're trying to keep the repository clean. And this file is more of a configuration file. So it could have things like which region you're deploying to and that kind of stuff. And that's not really something we need to commit at this point. The other thing is last time I was fiddling around with Amazon Q and Code Whisperer, and some things were working and some things weren't. I wanted to just sort of see if they were working today. So Yeah, so now you can kind of see, oh, and look at this. This is interesting. So you can't see. I can see it, but you can't. Let me fix that real quick. I know how to do this. So if I present my whole screen, I think you might be able to see this, although it's going to be a little small. Yeah, okay, cool. So let me make it super big. See if this works. So Code Whisperer on the command line is really nice. So if you type like CD space, it's really tiny still, sorry about that. But you'll see it'll start to type things ahead for you. So it'll give you suggestions about where I'm trying to change directories, and you can go and just pick one. But also, if you do things like SAM, it'll suggest to you the rest of the commands. So like SAM build, SAM delete, SAM deploy, SAM init. So if I do SAM build, and then I hit space, it'll give me even more options as I go, and it sort of helps me figure out what command I'm trying to build. So it's super handy. And then the last thing I really like about it is that you can type CW for Code Whisperer AI, and it'll put you in this sort of like interactive mode where you can type things like, what is the command to sync a file to S3? And so you can do that, and it'll actually just come up with the command for you right there. So here's the command, and you can actually execute that command, or you can edit it, or try again, and we're just going to cancel for now. So it's a pretty useful tool. I really like having it in there. Let's make this back to a normal size. And then the other thing, last time we looked at Amazon Q, which for some reason wasn't really working for us last time, but now let's try some Q stuff. So let's ask it, how do I write a Lambda function in Go that puts an item into Dynamo DB. See if it can help us with that. Okay, yeah, it worked. Look at that. So it's generating an answer for me. I can scroll up a little bit so you can see this. Well, it'll give me quite a extensive answer. So it gives you an example, Go function. I didn't specify which version of the SDK to use, and it looks like it's using the old version, but I've tried this before, and if you specify to do it in version 2, it'll do it in version 2. But then look, it gave me all the code that I need to think about, so it's pretty good example code. And you can insert this right into your code using this button, or you can copy and paste it depending on what you are trying to do. And then it also, what I think is really important, is it gives you links to the sources, so where it got that code sample from. So in this case, it's getting it from our own AWS documentation website. But if it was from like Stack Overflow or some other source, it would show you that here as well. So it gives you an idea of where the answer is coming from. So it's very handy to have this guy in here. All right, I'm going to go back to a different windowed mode here so we can see things a little bit bigger. All right, there we are. That was actually pretty good. Cool. Okay, so enough of that. So let's start looking at our code, and I want to talk through a little bit about some errors and some things that we did a little bit funky last time that we can fix this time. So the first one that I'd like to work on. So here's the thing. So basically, like the way I kind of operate is just make it work. Just write some code, get things up and running, see if they function properly, and then go back and try to like refactor things and make things a little bit better. I think in like a future session, maybe we'll get into test-driven development and writing tests. Writing tests in Go is really nice. It's set up for building tests, but it takes a little bit of, it's a different mental model. So you have to sort of basically write the tests first and then write your code and sort of test as you go. So yeah, there's a little bit of a different way to think about it. And once you kind of get into that frame of mind, it's actually very powerful. It's a very efficient way to work, but we'll get there. So that's the topic for another session. For today, I just like to kind of go through and look at what we've done and start to refactor things, fixing up some stuff we did wrong last time, and making our code a bit cleaner. And so the first thing I thought we should look at, so let's see, where's our handler function? First of all, it's getting really long. Like this code is starting to get kind of lengthy, so we probably want to start breaking things out into different packages. But before we get to that, I think what I'd like to do is talk through errors. So last time we put in a number of errors based on what's going on step by step here. So for example, one of the first steps we have in our handler is to try and get that poem from DynamoDB. So we have a function called getPoem. It returns the poem itself, which is a struct in Go, and it takes in an ID number as a parameter. And so if you look at the function getPoem, it's pretty simple, right? So we are always returning a poem and an error. And so that makes sense. We can come back to making this a little bit better in a moment, but yeah, all we're doing is returning the item and the error as we go. And so the errors can be all sorts of things. So in this case, like poems table environment variable is not set, or we're having trouble talking to the database. We're having trouble unmarshalling from the database. So all these potential errors we're capturing here. This one here, I'll come back to that in a little bit. Okay. But so the function just returns the error or the poem. And then what we're doing here is we're saying if we've got an error, log a fatal. And so when you log a fatal, here's what happens. So two things happen. First of all, it'll print out your error to the logs, which is good. So you can go into the logs and see what has happened, but it will also crash the program. And I think for like a command line program or, you know, in a lot of other cases, doing that might be just fine. But in a Lambda function, what does that mean, right? So if we crash our program while it's running, uh, what does the user get? So I guess the point is here, we don't really want to crash the program. And that's what was happening last week. What we want to do is return the error to the client through API Gateway. We want to tell our client, here's what the error was. Now you can deal with it on your own. So basically, what this will wind up doing is if it'll produce like a internal server error, which is very non-descriptive. Really, it doesn't really tell you much about what's going on. And then API Gateway will just sort of time out after it's 30 seconds or so. So what we really want to do is this. We want, just like here, where we're returning a success, right? Status code 200 and the poem. Instead, I think what we want to do is return the error and some other status code, right? So we can still log the error just like this. So we have it in our CloudWatch logs. But if we do this, I think our client will be more happy. Okay, so let's first of all, let's take a look where else are we doing this. So we're doing it right here. If we get an error from the getPoem function, we're logging a fatal error. If we have a poem, we're just returning it. So that's correct, I think. And then there's a bunch of them. So if we have an error getting an artwork from Cleveland Museum of Art, we're logging a fatal. If we have an error from sending that prompt to Bedrock, we're logging a fatal. Here's again, if we're having trouble writing the poem to the database, we're logging a fatal error. And finally, if all goes well, we just return the poem there. So we have a bunch of spots where we're returning or we're crashing the program potentially. So I think we want to fix that first of all. So let's try and do that. All right, so it's actually just the same as this. I can actually just copy. Well, let's get rid of the log fatal bit, and then we're going to add in, and instead of this, we already have the poem bit. We can put in our error for now. So what this will do is it will print the error to the logs in CloudWatch, just so we have it. And then instead of returning a 200 and the poem, for now, let's just return the error. We can't quite do that because an error is not a string. And also let's return some code. So for now, let's just return like a 500 because we don't really know what this error is. And we'll talk about how to deal with that in a minute. So for this, what do? We turn it into a string, or actually we can do that. So error.error, that should actually print out the error for us. All right, so let's just pretend like this is going to be fine for most cases. We'll do this for now, and then we can always come back and make this more sophisticated, right? So like a 500 is not really a great error to return all the time unless we know it's actually a server error. We might be a 404, right? If we can't find the poem or we can't find, we have to sort of think about what we're responding with. But for now, let's just do that to make things work a little bit nicer. So here's another log fatal. And so this one is if we can't get an artwork from Cleveland Museum of Art. So for some reason, Cleveland Museum of Art is down, or we're having a network issue connecting with it, instead of logging a fatal error, we're just going to log the error and send it back to the client as a 500 error. Cool, and let's do it here again. So if we have a problem with Bedrock, same deal. I don't think we need to log the actual poem anymore to CloudWatch. Let's just comment that out for the moment. And then here as well. All right, that's starting to look a little bit better. So now we've got all of our errors being trapped, basically. Okay. Okay, cool. So let's build that. Let me just make this a little bit bigger. Sam build. And what am I forgetting? Ah, yeah. So I want to, let me see if it's still in here by some chance. My history. Yes, so I want to keep this same thing. So I'm just setting up an environment variable here for the name of the table, the poems table. It's going to be the same thing as last time. And then I'm going to try Sam local. Look at that start API. Do I have Docker running? No, I don't. Okay, hang on a minute. Let me get Docker running. Where are you, Docker? There you are. Okay, let's see if it works. Is Docker? Here we go. All right, it's loading up. Hi, Docker. Okay, let's try that again. All right, there we go. So now Docker is running. And so let's make a new, let's make a new terminal. So I should be able to do curl, and then this, and I want to put ID equals, and we need an ID. So let me just grab the one that we just made before. All right, and let's take a look at what's happening over here. So it's spinning some stuff up, and I think, oh, it's done. Yeah, so there, it's got our poem just came back while I was over there looking at it. Okay, cool. So it's worked. But what if we get an error? So how do we force an error here? Let's see. Well, we could try to get a poem that doesn't exist. Let's put in like 0, see what happens. Could not fetch data, 404 found. Look at that. All right, so we got back our error. Okay, so let me just talk through what we just did there. So that actually worked. Okay, so, and we can stop the API. So I tried to send it artwork 0 to the Cleveland Museum of Art. There is no artwork 0. And so if we look at our Cleveland Museum of Art uh, get artwork function, if okay, so if we don't get a 200 back, um, it means we weren't able to find the artwork. And so if I go to Cleveland Museum of Art's Open API and I look for artwork 0, I'm going to get a 404. So the object is not found. And so could not fetch data is the error we got, and then the actual error is 404 not found. So that's exactly what happened. Okay, so we're actually capturing that error properly now. The Lambda function is not hanging out there waiting for the timeout to happen. So we're not crashing our Lambda function anymore. Our API gateway is happy. And now we are returning our client error messages of some kind. Cool. All right, so that's nice. That's good. Let me go back into here now. Okay. However, we are sending some funky errors, so we're going to have to think about how to deal with that a little bit better, because as you just saw, we got a 404 error back from this, but we're sending it a 500 code. So that's kind of funny. We're getting a 404 from Cleveland Museum of Art. We want to sort of send back to our client the same kind of an error because it's really the same thing, right? There's no artwork of that ID. Um, and so somehow we need to sort of trap that status code and pass it along to our own client. But that's kind of a funny thing because if you go up here, right? So if we try to get it from the database and it doesn't find it, that's not really a 404, right? That's something else, right? So anyway, I have to sort of think about what we should really send back. Okay. But anyway, we got a better error handling going on here, which is good. Okay, cool. So I want to sort of deal with another issue from last week that I didn't get to deal with, which was in this function up here. So in the get, where is it? In the get poem function. All right. So last time I kind of got around an issue by doing something a little weird where I declare a new variable called item as a type poem. Because basically, as you might recall, let me just type some stuff here so you can see what it looks like. I'm returning a poem and an error all the time, right? And so what it means is I can't return like an empty string because poem is a struct, not a string. And I can't return nil because I don't know why, because I just can't return nil, which is really what I want to return. And so to get around this, what I did was oops, one sec. Okay, what I did was I created an empty struct called item, and so I'm just returning that empty struct here, here, and here. It's kind of funky, and the reason is because what we really want to do is return a pointer. Okay, so what we're doing right now is returning a poem by value, basically. So we have to create a poem first, and then return that poem each time. And what we really want to do is return a pointer, and then rather than returning doing this business, I think what we really want to do is return nil. Okay, so this is nice. So if you're returning a pointer, you don't have to return like an empty struct. You can just return nil, and that's really like the way to do it. So I can go through here and change all these to nil. Nil. And instead of item, let's fix this first. Nil. Instead of item, I'm going to return poem. Right? Oh wait, that's not right. Oh yeah, okay. Poem. So I want to return. What am I doing? Oh, poem.item. Okay. Oh, is that what I want to do? Let's see. Oh, because it's okay. Yeah. All right. So it's. I see what I'm doing. So here. This is interesting. So what I'm doing here is I'm declaring a variable called poem. But you can see the poem is actually like a DynamoDB get item output type. And what I'm returning here in my declaration is a pointer to a poem. And up here, I've actually created my own struct called poem, which just has an ID and the poem itself. Okay, so I can do two things. I can either change this so that I'm actually returning the DynamoDB type, but I don't really want to do that. I want to return my poem. So what I have to do instead is I have to marshal this poem onto this my own struct, basically. Or actually, I don't even have to marshal it probably because it has. Um, let's see. Yes, I do. Because it gives me an item, return item. Um, one second. Let me just remember what I did here. Oh yeah, so I have a DynamoDB thing, and then I have a poem. So I thought I've already done this. Let's see. Yes, I have. Okay, on Marshall map. Okay, this is what's throwing me off here, is we have this bit here. So let's comment that out for a moment. We'll come back to that. So I did create, so I am creating, so let's do that, sorry. All right, so item, poem, and then I'm using the unmarshal map function here to basically copy what's coming back from DynamoDB onto this poem struct. And then here, same thing, I just return the item. But I need to return pointer to the item. Exactly, okay. So that should work now. So this part here, what was I thinking here? All right, so I went through and tried to capture different errors, right? So if we have an error setting up our config um, to AWS, we might get an error from that, so I'm returning that as an error. And then if we don't have an environment variable set for the table, that's a possible error. Then we try and get the poem from the database. And if we get an error talking to the database, we capture that and return that error. And then if not, we just want to return the poem. So what was I thinking here? If poem.item is nil, return the empty item and no error. Okay, that I think that was a workaround before we had this pointer in place. So I think we don't even need that anymore, but let's leave it here as a comment in case we do. So I think this makes sense now to me. So yeah, so let's go and fix this in our handler. Because now we are getting back a poem. Actually, it might be all good. We're getting back a pointer, and then this still is true. Yeah, I think we're good. I don't think we need to do anything different. But yeah, okay, I think that actually makes sense. So let's give it a try. Let's do a build. Looks like it built. Let's run the API. Okay, seems to be running. And let's do this same command here, except let's do a real one. And it works. Okay, very good. I got our poem back. Okay, so the code works. Let's just take a look, a little bit closer look as to why. So I know that was a little confusing. All right, so first of all, let's go back up to our get poem function here. Okay, so just to recap, what we did was we changed the return to being a pointer to a poem rather than a by value return to the poem. What that allows us to do is we can return nil if we have an error. So we don't have to actually return like an empty poem struct. Instead, we return nil, which is much cleaner. So we do that a number of times for different cases. And then when we get down to here, before what I was doing was I was checking if the item returned was empty. And if it was empty, I was just returning like the empty struct. Um, because when you make a call to the database, your response might just be, we don't have that poem basically. And then rather than doing that, I'm just creating our struct here, our variable here, and then marshaling our response from the database onto that item, and then returning the item itself. So the and symbol here basically dereferences that pointer, so that back here in the handler, where we say poem equals get poem, we wind up with a variable that contains the actual uh, poem object. If that makes sense. Yeah. Okay. Anyways, seems like it works. So let's do one other test here, just while we're here. I want to see what happens if we try to get a poem that doesn't already exist in the database. So let's start our API again. All right. Let's flip over to this terminal. So we know that one exists, right? So if we do that one, we get our poem back. But if we do this, where was it? 0, right? 0 shouldn't exist. So we should get an error. Let's see what we get. Cool, same thing. So this works. All right, so what this means is that, let me just show you in the code what happened. So we tried to get our poem from the database. Uh, we didn't have a poem in the database, but that's okay. That's not really an error. So we're not going to return the fact that we couldn't find it in our own database. Right, so we're going to try, since we didn't find it in our own database, we're going to try and um, generate that artwork. Right, so we tried to get the artwork from Cleveland Museum of Art, but that artwork doesn't exist. There is no artwork 0. So we do return an error here, and it's a 404 that comes back to our client, even though we're sending back a 500. Okay. So that works. That's nice. Let's see. What can we do next? All right. So I think this means we can get rid of this piece. That was sort of a workaround from last time. Let's just clean it up a little bit. And let's take a look at what's changed. So close this shell so you can see. If you go into your Git tab here, you can click on a file that's changed. It's a little hard to see on this screen because I'm so zoomed in. But you can see that we are no longer using the log package anymore, so it's in red. And then down here, you can see what we've changed. So you can see we changed what we're returning. We're returning a pointer now instead of a struct by value. We got rid of this line here, and then we changed all these from item to nil. So just sort of a visual way to see what we're doing. Okay, so that works. Let's close this. Let's open our code, our command line again. Let's deploy it. All right, so let's do sam deploy. See what happens. I haven't deployed anything since last week, so let's see if we're all good. Okay, looks like we are ready to deploy our change set. Awesome. Okay, so it's deploying our code with our new error handling in place, which is nice. And it's done. All right, great. So now we should be able to hit this URL. Let's just do it from the command line here, curl, and let's add ID equals, let's do ID equals 0 and see what happens. Same thing, we get our could not fetch data 404 not found. And then if we do one for an object that does exist, one that's in our database, let's try that. So we know we have this one in our database. We get the artwork back right away. That was super fast. That's nice. Okay. And then if we do one that's not in the database, so let me grab a new one. All right. Let's see what happens if we do this one, 152776. So it's going to take a little bit longer. And there it goes. Now we have a new poem. And then if we do that one again, it comes back right away because now it's in the database. All right, so it seems like things are starting to work. Pretty cool. Let's go and look over on the console and see what's going on in AWS. Hang on one second. Let me switch my screen. I believe it's this one. Okay, so let's go over to AWS. Okay, so we can rerun. So now we have 6 poems. So we're starting to build up a little library of poems. So that's pretty cool. So this is DynamoDB. Let me just give you a little quick tour. So here's DynamoDB. You can go over to your tables. Here's the table that we created with Sam. We have one partition key, which is our ID, and it's a type of it's a string at the moment. We don't have a sort key. That's okay. But if you want to, a good sort key might be something like the date we are creating the poem, because that way you can do things like generating poems over time. So we can generate different poems for the same artwork. Just use the date as a way to indicate the uniqueness of that poem. But we're not doing that. And so then we can go into our poems table and take a look. So what's nice about DynamoDB is that it's kind of like all right here for you. So you can look at your configuration of how your table's set up. You can look at charts and graphs of how it's being accessed, your read usage, your write usage. You can set up alarms, all sorts of stuff. Back up your data, so on and so forth. Exports and streams is a very powerful capability. So we can create events. Anytime we create a new poem, we can fire off an event and have some other application or some other function react to that event, which is kind of nifty. All sorts of creative uses for that. But what we can also do is just explore the table items. And so we're just using the scan method to search. So we can just click run. And now we see all 6 of our poems. And you can go and click on one. And you can actually see, and you can actually even edit the item right here in the console if you want. So there's our poem. That's kind of cool. You can look at it in this form, or you can also look at it in JSON view, either one. And that's basically it. So as we kind of, send it new poems to look for, it'll just keep creating them. Okay, so our project works. Yay. All right. Are we done with it? I don't know. I think we've got some more stuff to do with it before we call it done. So let's talk about what some of those things are. So let's go back to our little diagram here. So it's aside from the CloudFront, I don't want to do the CloudFront part right now because it's not really too exciting, but let's talk through the rest of this. So it's actually working pretty well now. So we've got our API gateway here. We can add some labels for us all so we know what things are. Oops. I'll get back to that. All right, so we can call this, let's put it right here, API gateway. Yes, we want to save. Okay. API gateway. And then we have this function, our one Lambda function, which I think was called like generate poems. Something like that. And then we have a DynamoDB table. Let's put a label on that. Poems table. And then we have Bedrock, Amazon Bedrock. All right, that looks nice now. So now we know what things are. All right, so let's just kind of go over it again. So we've got our API gateway. So a request comes in to API gateway. It's currently a GET request. And you can pass it the ID for an artwork using a query string parameter. So we set that all up like in the first part of the project. That will invoke our Lambda function called generate poems function. And this will first check the poems table in DynamoDB to see if we have an existing poem. If we do, we just return it. If we don't, we start to go through this part of the process. So if we don't, we call up the, let's put this CMA, Cleveland Museum of Art API. We get the information for that artwork that we're looking for. If we don't find it, we get a 404 back. If we do find it, we use that to craft a prompt, which we send to Amazon Bedrock using Claude Instant as our large language model to generate a poem, which gets written to the DynamoDB table and then passed back to our client. So that is the flow. It seems like when we're doing these, it takes about like 6 or 7 seconds every time. So that's okay. It's within sort of like the 30-second time limit we talked about last time. But it could take a long time to generate a poem. So we might want to think about adding some error handling in that case. But I mean, it will handle the error at the moment. It'll just tell us we got a timeout error. But there might be a more graceful way to fail there. But anyway, yeah, this is all working now. So I think what we want to do next is kind of make it a little cleaner. So one thing I noticed that's kind of funky is that when we make our API request here, we're just getting back like a blob of text, right? So this should really be in like a JSON format, right? So this is instead of just sending back a text blob like this, uh, there should be some JSON telling our client like what this thing is. So our client can consume this response in a much more straightforward kind of way. So that's one thing we can do. The other thing is that it always says this at the top, right? It always says like, here is a short poem inspired by the artwork. I don't know if we want to, if we want that. Um, because if you think about it, like, what are we going to do with this? If we want to make like a website, uh, or I don't know, some kind of like maybe an email or whatever our output is, I don't know if we're going to want to keep this little response from the large language model. This is like the voice of Claude. So I don't know if we want that to be in our response. We really just want this bit, right? So we're gonna have to, I think we want to play around with how we craft our prompt a little bit to clean this up. So we can do that. And I think we want to wrap this all in like a JSON object. So that's two things. I had another idea too. Let's see. No, that was it. Those are the two things I want to do. So let me, hold on. Let's see. So what are we going to do first? Why don't we do the JSON bit first? Because that's probably a little more straightforward. Okay, so let's switch screens back to code editor. Here it is. All right, so we're back on code editor. And you can see right here, even when we get our response back from our API, it's like just basically text. Okay, so that's no good. We want to wrap it in some kind of a JSON object. Okay, so how are we going to do that? So let's take a look at what we're doing. In our handler function down here, if we look, what we're always doing when we have a successful poem retrieved, even if it's from the database, we're just sending it back as the body itself. So we really need to put that into a JSON object. So we're doing it here when we have a poem from the database. Uh, we're also doing it with all the errors we send back. All of our errors are just going back as um, text. So that's also, we need to put that into like some kind of a JSON object too. And then down here, finally, at the end, when we do have a successful poem generated, right here, same deal. We're just sending it back as text. Okay, so it's pretty simple. Basically, we want to, first of all, let's make a struct that can hold our response. All right, so up at the top here, let's just define it up here. So we're going to make a new struct type. Let's call it response struct. Okay. And look at this. Code Whisperer is already on the case. So Code Whisperer knows we're making this. So we didn't have to write anything. It just did it for us, and we don't get that right now. So we have a struct. It has a single object called message, JSON message. I think we also want to add an error, right? In case we have an error, why don't we just send it back as error like that? That might be nice to do. Okay, cool. So if let's go back to our handler. And let's not, I guess what we will need to do is we'll need to marshal our response. But we already have, let's see, we already have a, okay, so in this case, all right, we get an error back, right? So what we want to do is we want to create a response object basically and put in our error, right? So here, let's type this response, um, not message error. We want to say error, oops, error colon error dot error, right? And oh, and it has to be, well, we haven't used it. Okay. And then what we need to do is marshal our response. So let's make a JSON response. And let's, thanks, Code Whisperer. We don't need the error here. We need an underscore. I'll talk about that in a second. Okay, so we're going to marshal our response onto this variable here. And then instead of returning error.error, we can return JSON response. Whoops. That doesn't work. Oh, because it's a byte array, and we're looking for a string. So can we just do string? Okay, well that works. It's not the prettiest code in the world, but that would work. And what we can do is we can do this everywhere. So let's clean this up a little bit, get some space out of here. But basically this bit here, anywhere we have an error, this we have a success. So we'll come back. Actually, we can just do it right here. Okay, so instead of an error, we're going to put message. Our message equals poem dot poem. I don't know why we're calling it message. I think we want to call it poem. Yeah, let's do it like that. All right. And then here, we're going to do string response. Not response, JSON response. Okay. All right. So there we have to change this from message to poem because that's really, we're really being specific here. We want to, instead of message, we're going to call this poem. And here we call this poem. This is all going to make sense someday. Okay, so let's keep going here. All right, so then, where am I? Here we are. Okay. All right, so we're sending back the JSON response as a string. In this case, we're sending back a poem. Let's do the rest of these errors because that's basically copying and pasting this. All right, so here's another error. And then instead of sending back this, we're going to send back our JSON response. Up string JSON response. It feels like we should probably put this in a function, but we'll get to that eventually. All right, so here again is an error. Same deal. String JSON response. Okay, that's nice. And there's another one. Okay. And then finally the poem. And so here, instead of sending back just the poem, oh, I'm sorry, there we go. So now we're going to send back the poem, and it's poem.poem, or new poem. in this case. All right, new poem. And then instead of sending back this, we're going to send back do. All right, cool. Let's see if this works. So let's build it. Actually, that's fine. We still have our thing running from before. Okay. So let's build it again real quick. Okay. All right, and then let's run our local API. And let's curl the local API. See what we get. Okay, all right, looks better. Poem. So now we're getting a bit JSON response back. Handy tool you can do is pipe this into Python -m json.tool. It doesn't like it. That's interesting. I wonder if it's because of this ampersand at the end here, or percent symbol, because it looks like regular JSON to me. But that's pretty helpful, actually. I think we have a little funky thing going on there. So let's take a look. Okay. What are we doing? We're marshalling our response. And then we're returning it as a string, which seems okay to me. All right, well, while we're just messing around here, let's do this. Let's do a SAM deploy. I want to see it working in the browser or in the, let's see here, okay. Okay. So it's updating our function on AWS. Seems to be done. So we should be able to do that right there. Yep, and now it's working. So we get back a JSON object. And it's got an empty error at the end of it, which I think is all right. Oh, I see. Everything is got /ns in it. I see. I think JSON tool doesn't like this because of all the escape characters and stuff in here. But I'm okay with that. All right, let's see if it's gonna give us the same issue. Yeah, same problem. So it's not really valid JSON at the moment. Oh, that's because I put in just Python. Let's try this, Python 3. Okay, that works. All right, I was putting in the wrong version of Python. All right, so all this does is it sort of does like a pretty printing for us. So it's indented a little bit. Gives us our poem object. So here's the poem. And then our error object, which is empty at the moment. Let's try it with object ID equals 0. Taking a little longer. It's nice you get a little timer here when you use JSON tool. Okay, so we get an error. Could not fetch data, 404 not found. All right, this is This is better. It's actually working. Pretty cool. Okay, so we made a service that's returning a JSON object. Of course, we did it kind of by the seat of our pants, and it's a little bit ugly, in my opinion, in terms of how the code is written, because we're repeating ourselves quite a bit. Uh, so we might want to put some of the stuff in a function, but I think also um, like the code itself overall is getting quite long. So it might be wise to put some of these other things in packages as well. So we could do that to make it a little bit more reusable. And that's the whole idea. So if you create a pack like we did for the Cleveland art package, what's nice about this is if I create another Lambda function in the same code base, and I want to use this get artwork function, I can use it very easily because it's in its own package. So that's as you kind of start to build some more sophistication into the application or whatever the services you're building, it makes sense to start separating some of these things out into their own packages so that you can reuse them in different places. What's really cool about Go also is that you can use these packages from other modules from other applications. So if I host this whole project on GitHub, um, somebody else can write their own application and just use the Cleveland Art um, functionality here, package essentially. So how does that work? Like, so same thing, if we're in our main program up at the top here, you would just import the same thing, except it would have like the GitHub URL, just like these do here. Right, so it would say like github.com/ whatever your username is, uh, wherever you host your code, and then the name of this repository plus the /Cleveland Art gives you access to that package. So we're doing like a local package here because it's right here within our own code base. But if you wanted to use it from a separate application, you would reference it with the full URL. And so it's kind of fun because you can actually access packages that are within a project like this, or you can separate this out into its own package. So you can make just a standalone package for Cleveland Art, whose only purpose is to talk to the Cleveland Museum of Art's Open API. So yeah, a couple of different options in terms of how we structure things. I think in terms of this project, we have a couple of ideas of what we could do next. First of all, we could start moving some of these things out into a separate package here. So I think there's a lot of stuff. So there's definitely some DynamoDB functionality here, like the put poem and the get poem function, which we could separate out to its own package. There's also the function for sending our code, our prompt to Bedrock. So we could make kind of like a Bedrock package that does the send to Bedrock bit, but also maybe does like the craft prompt bit. I don't know. Craft prompt is a little bit specific to this one function. But the other thing we could do is add another route, another method, like another whole Lambda function to this. So let's talk about that. So we have like 20 minutes left, but that might be a fun thing to experiment with. First, before we do that, let's commit our code. All right, so let's go here. And okay, so one thing, when you're learning Git, if you're new to Git, I recommend doing it on the command line because you'll learn what the commands are a little more easily or faster. Once you know it, the plugin for VS Code makes it really simple. You just click like the plus, do the commit, you're all done. So let me show you what this looks like on the command line. We'll just do a git, status. You can see we have one modified file, so we can do a git add, and you can either specify the file itself, just like that. Code Whisperer is helping me there, or you can type dot to do the whole folder. And then if we do a git status now, you'll see we have a modified file. So now we can do a git commit -m, and let's come up with a message. Let's say we refactored and added error handling. Whoops. All right. And if you do you can do a git log, and that will show you. So I had one commit that I did last week, and then I have another one that we just did right here. So you can see all your commits like that. All right, that's nice. I will put this code on a repository very soon, so you can take a look at it. All right, so let's talk about this other route idea. So I have an idea. Let me just switch over to the other screen here. Okay, here it is. So this is what we currently have, right? We've got this one function, and all it does is it lets you pass an ID through the query string parameters to get a specific artwork, and use that specific artwork to generate a poem, store it in the database, so on and so forth. But what if we don't know the ID? What if we just want to get like a random one? How could we do that? So that's one thing. Or what if we want to search, right? What if we want to put in like, rather than an ID, what if we want to do it with like a keyword, like show me, generate me a poem for the first object that comes back when I search for chairs or something like that. So those are also possible things we could add to it. So just starting to think about adding more functionality to the service. So there's a couple ways we can deal with this. One is we can add more functionality to our existing Lambda function to deal with other routes, right? So in this scenario here, we have a single get route on the root of the URL, and we're passing a query string parameter to tell it the ID. So we could add some more sophistication to our handler to deal with more routes, right? So or more parameters, right? So maybe we add a parameter called random or something like that. And then we can handle that differently in the Lambda code. Another approach would be to add a whole nother function to handle the same thing. So what we can do, let's just sketch this out a little bit. So we could add a second function here. So this one could be more like generate poems by ID, right? And then this one could be generate a random poem. And then the thing is, it's going to do a lot of the same stuff, right? So we're going to have to basically, the whole point of this function is going to be to come up with a random ID. So it's going to have to make a call to the open access API for Cleveland Museum of Art, find out how many objects there are, and it's going to have to come up with a random ID or a random number in between 0 and the top limit of whatever, however many objects there are. And then it's going to have to request an object from that index. And you're not requesting the object's ID because we don't know if there's missing IDs, that kind of thing. We'll actually have to use it as like an index to give me like the 100th object out of all the objects or something like that, whatever the random number generator comes up with. But then from once you've got the ID, everything else is the same, right? So I think in that case, it makes sense to keep it all in the same function. Or maybe not. I don't know. Still thinking about this. You can do it in the same function, but the code might get a little messy. Or you could separate it out into another Lambda, but then you might be repeating code. So I think it comes down to kind of how you structure things a bit. But at the very least, we could start by thinking through how to get a random object. All right, so if we look at the Cleveland Museum of Art API, hang on a second. The API method that we were working with before requires a specific ID. Here it is, get artwork specific. And so you pass it an ID and it gives you back that response, the exact object you're looking for. And that's all good. But how do you get like a random one? You can't. There's no method called get random artwork. There should be, but there isn't. So what you could do, sorry, scroll up a little bit. You could use the search method. Where is it? Here it is. So get artworks, plural, uh, which is synonymous with search, essentially is what they're saying here. Okay, and so all that really does is it lets you put in a search string. So you can search for something. One thing to know about with the Cleveland Museum of Art is if you don't put anything in, you're going to get back everything, which is kind of interesting. Watch this. If I just click on that, it's going to take a little while, but I get back 66,682 objects. Now I don't get all those at once. There's a limit parameter, which is two. I know. So sorry, this is very small. I don't know if I can make this any bigger, actually. Yeah, it's freaking out. All right. Anyways, so oh, there it goes. All right. So it tells you the total number of objects in the collection at the moment, and then there's a limit. So in order to not um, crash a server somewhere, you're limited to there's an upper limit, I think, of 1,000 objects at once. And there's a skip parameter. And the skip parameter lets you skip over, it's basically a pagination mechanism. So you can skip over, say, like the first 1,000 objects and get the next 1,000 objects. Right. So we could use this um, to get a random one, right? So we could say, uh, first of all, give me all, just do a single call to get this information here, so we know how many objects there are, because this number might change, right? So that's the whole point. Um, Over time, this should probably increase as they add objects to the collection, or maybe it will decrease if they remove objects from the collection. But the point is, we don't know; it's not a fixed number. And so what we could do to get a random one is, first of all, make a call to find out how many objects there are, and then generate a random number between 0 and that number, so 0 and 66,682. And then we can uh, search for all objects, but we can say limit it to one response and skip to the random number that we generate. Will that work? I think that'll work. Yeah, let me see here. All right, now everything's really big. Hold on. Let's see. Skip and limit. Yeah. All right, so let's just try it right here in a query string. So we say, let's pretend our random number is 100. So we say um, skip equals 100 and limit equals 1. It worked. All right, so it skipped the first 100 records, and it's giving us just one record back. And it's this record here. It's just here it is. And it's slightly different because when you do the artworks search API method, it's giving us an array. So rather than, if you look at the documentation, rather than giving us a single object back, it's giving us this data object, and it's giving us an array of all the responses. That's fine. And it also gives us back some metadata here. basically it tells you what you searched for. Oh, and by the way, you can also search for stuff. You can put in keywords and all sorts of other parameters. So this is pretty cool. So yeah, I think we could totally use this to get a random object from the collection. So what I would do here, we only have like 9 minutes left now. So let me switch back to code editor. Okay, so what I would do to start working on this, before I even get into how Lambda is going to deal with this uh, as a handler, the first thing I would do is start building out this functionality in our package called Cleveland Art. So right now we only have one function in here called get artwork. And it just returns the full document as a byte array based on a string, or I'm sorry, an ID, right? So we can make a new function called get random artwork. Right, so we could say like func get random artwork. And this we don't want to do that. We don't even really need to pass a parameter, I don't think. And we might want to return exactly the same thing. So we might want to return a byte and an error. Code Whisperer has got all kinds of ideas here for me. But they don't really make sense because it's assuming there's a random, that's kind of cool. It's assuming there's a random API endpoint. But some of this other stuff might be useful, but we're just gonna skip over Code Whisperer for the moment. And so let's just kind of like stub this out a little bit so that next time we can come back and write this function. So first of all, it's going to have to return let's just say it's going to return a artwork and an error. Okay, and for now we can just type nil and nil just for fun. So let's just say we're going to return an artwork. Oops, artwork doc or end error. And then before we do that, so let's just type out what this function is going to do. So it's going to call CMA artworks endpoint to get total number of objects. Generate random number, between 0 and total number of objects. Thank you, Code Whisperer. Call CMA artworks endpoint with the random number as ID, not quite. It's not going to be as the ID, it's going to be as skip parameter. And that's it. So that's what we're going to build next time. So it's going to use a slightly different API. Well, it's actually the same API endpoint that we used before. Artworks is the only endpoint there is, but we're going to use some different parameters. We're going to use the skip parameter, and we're not going to be passing an ID. We're going to be passing, skip and limit. While we're here, while we're just kind of sketching this out, this can be moved outside of this function as a global constant, like that, so that we can use that global constant elsewhere in other functions. So that still works. So constant endpoint equals that. And so this, it'll be a little bit different. I'm just going to put this in as a comment for now. So So I remember what we're doing. So instead of passing as an ID, let's do it like this. Limit equals 1 and skip, oops, skip equals percent v, I think. And instead of ID, we're going to say like skip. Okay. So this is just some food for thought for next time. So we're basically doing the same thing down here that we did up here. But instead of passing it an ID, we're going to pass it these two query string parameters to limit it to one response and to skip to whatever number we randomly generate. And so we'll have to learn how to randomly generate numbers as well. All right, that's pretty cool. So that's a good idea. And what that will do, that'll kind of make this a little bit more fun because we'll be able to just hit the a get random artwork, uh, our own endpoint, and rather than having to look up an artwork ID, we'll just get a random one. That might be fun. And also just thinking out loud, that might be dangerous because there's 65,000 artworks in the collection, and someone could easily just click or write a loop to generate them over and over and over again, which might cost a little bit of money. So we might want to add some authentication to that endpoint so that only uh, people we like can do that action. But we'll get to that when the time comes next time. Okay, I think we've done enough for today. Let me just stop the screen share. I'll switch back to here. Cool. All right. Well, that was fun. We refactored a bunch of stuff. We have our errors working properly now, so we're not crashing our Lambda function anymore. And we're returning an error back to the client. It's still a little bit messy in terms of code, so I think we're going to have to refactor things a bit again to make things a little bit cleaner. But that's just how it goes, right? We build stuff, we refactor, and we rinse and repeat. So yeah, so maybe next time we'll finish working on this get random artwork idea, and then we'll start looking at like testing. I think it would be nice to have some tests built in at this stage and start doing some test-driven development. Uh, yeah, because that's a good thing to do. But that is basically it. It was great chatting with you today, and looking forward to next week, same time, same place. Uh, have a good one.